Now the first question is, give the name of the process that is used to produce ammonia from nitrogen. Here we all know that this is the Haber's process. Haber's process. Second part, to separate nitrogen from liquid air. So see, we are taking air, we liquefy the whole air and then we separate nitrogen from it. So this is actually done by fractional distillation. Fractional distillation. Now, to produce bromine from molten lead to bromide. Now this is done by electrolysis. So electrolysis, and the bromine is obtained on the positive electrode. To separate an undissolved solid from an aqueous solution. Now undissolved solid that can be separated by, to separate it from the aqueous solution, what we will do, we will filter it. So for this we write filtration. Filtration. Now to produce amino acids from proteins. Now see, what are proteins? Proteins are polymer and amino acids, these are monomers. So what process you will use is hydrolysis. Hydrolysis, actually this hydrolysis to break amide linkage and to separate a mixture of amino acids, of course that is chromatography. This is chromatography. And students, if you like the video, please do like, share and don't forget to subscribe. Thank you. Coming on to the next question. Now complete the table to deduce the number of protons, electrons and neutrons in the magnesium atom and copper ion shown. Identify the atom or ion represented by the final row. Now we know atoms and ions. So as you can see, magnesium, number of proton is 12. As you know, this subscript that gives you the number of proton and this superscript will give you the number of nucleons, means the number of protons and neutrons. So as you know, this is an atom. So this magnesium is an atom. So number of protons means total positive charge will be equal to total negative charge. So total number of protons and electrons, they are equal. So this is 12, this is also 12. And to get the number of neutrons, you do 25 minus 12. You do 25 minus 12, this equals 13. So the number of neutrons is 13. Cu2 plus 65, 29. So this is the number of protons only, 29. So number of protons is 29. See number of electrons. Now this is an ion. This is the positive ions which has lost 2 electrons. Suppose it would have been an atom. So number of electrons would be 29. But since it has lost 2 electrons, so number of electrons is 27. Now they have given you number of protons. So we know that by proton it's chlorine, 17. Number of electrons. For an atom, number of protons should be number of electrons. That means it should be 17. But it has plus 1 electron. That means it has 1 electron more. So you write minus 1 or just write minus. And number of neutrons is 20. As we know, this represents the number of nucleons. So number of nucleons will be 17 plus 20, which is 37. Yeah. Now, potassium reacts with chlorine to form potassium chloride, KCl. Write a chemical equation for this reaction. Now for this reaction is simple. This is potassium plus chlorine gas. It forms KCl. It's an ionic compound. And now we have to balance it. So as you can see, there are 2 chlorine atoms. So we write here 2. Also potassium, we write here 2. So this is our balanced chemical equation. Potassium chloride is an ionic compound. Complete the diagram to show the electron arrangement in the outer shells of the ions present in potassium chloride. Give the charges on both ions. So we know that potassium has total of 19 electrons. So in its outermost shell, it is giving one electrons to chlorine, one electron to chlorine, not electrons. So this will be +1, as it is giving one electron, and that electron is accepted by the chlorine, that will be Cl minus. So right here -1. So that means how many electrons? So total 18 electrons should be there. Now as for the potassium, we can see how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there should be 8 electrons in the outermost shell, so representing this. So hence we complete the electronic configuration of potassium. Now this, see, chlorine has 17 electrons. So let's denote this, complete the outermost electron shell for chlorine. Now it has 7. Now see, that one electron which has been added means now there are 18. So over here there should be 18. So that one electron is given by the potassium. So to represent that electron given by the potassium, write cross over here. So this is our complete electron dot structure. Molten potassium chloride undergoes electrolysis. State what is meant by electrolysis. So we know that electrolysis is the breaking down of an ionic compound into its constituent when you pass the electric current. Given that ionic compound should be in molten state or in its aqueous state. So what you will write? We can write breaking down ionic compound to its constituent by passing electricity or the electric current, and the compound should be in its molten or aqueous state. Yeah. Now, name the product formed at the positive electrode anode and the negative electrode cathode when molten potassium chloride undergoes electrolysis. See, they are saying molten potassium chloride. Now see, we have only two ions over here, K plus and Cl minus. So K plus being positive, it goes towards the negative electrode, which is cathode. So at cathode, what is formed? Potassium. And Cl minus being negative, it will go towards the positive one. So at anode, it forms chlorine. Okay. Concentrated aqueous potassium chloride undergoes electrolysis. Write an ionic half equation for the reaction at the negative electrode. Now see, over here is aqueous. Aqueous means it already has H plus and OH minus ions over here, as well as K plus and Cl minus ions. So at cathode, there will be two ions, H plus and K plus ions. So see, actually this H plus ions will be reduced. So you write H plus ion plus one electron, that will give you hydrogen. Now as we know that hydrogen does not exist as a monoatomic, it's a diatomic molecule. So you write H2 over here, these two electron and 2 over here. So this will be the half equation. Now name the product formed at the positive electrode. Now see, at the positive electrode there are two OH minus and Cl minus ions, but Cl minus ion is basically, this will be oxidized. So what you form, so what is formed is a chlorine. So at anode we have chlorine only. Now third one, name the potassium compound that remains in the solution after electrolysis. Now see, in the electrolysis, as we have seen, this is being used up and chlorine is being used up. So these two are left. It forms KOH, which is potassium hydroxide. So this is form which will be potassium hydroxide. Complete the dot and cross diagram to show the electron arrangement in the molecule of chlorine Cl2 minus. Show the outer electrons only. So see, chlorine has 7 electrons in the outermost shell, but it actually shares the electron. So first of all, writing this for chlorine, 1, 2, 3, 4, 5, 6, 7. So these are 7 electrons of this one, and again now representing the outermost 1, 2, 3, 4, 5, 6 and 7. So as you can see, these 2 electrons are shared and hence they complete their octet. So this is the complete diagram. The melting and boiling points of chlorine and potassium chloride are shown. Chlorine minus 101, boiling point minus 35. Similarly for potassium chloride, melting point and boiling point is given to you. Deduce the physical state of chlorine at minus 75 degrees Celsius. Use the data in the table to explain your answer. Physical state. So see, let me explain it to you with a number line. Now consider this as a number line. Now this will be minus 101 and this will be minus 35 and minus 75 will lie over here in between them. Now see, this is the melting point. So below the melting point, this will exist at solid state. Above the boiling point, this will exist at gaseous state, and between these two, this will exist as liquid state, because this is more than the melting point but less than the boiling point. So the physical state will be, as you can see, minus 75 lies between minus 101 and minus 35. So the physical state will be liquid. Explanation. So explanation is just the same as I have explained it. So what you will write, the temperature, the given temperature, which is minus 75 degree, is greater than melting point, which is minus 101, but less than boiling point, which is minus 35 degree Celsius. Okay. Now, explain in terms of structure and boiling why potassium chloride has a much higher melting point than chlorine. Okay, your answer should refer to the types of particles held together by the forces of attraction, types of force of attraction between the particles, and relative strength of the force of attraction. See, types of particle, we know KCl, potassium chloride, is bounded by it has ionic bonds. There are ions. And in chlorine, it is the molecular bond. Types of forces, in KCl, you have the ionic forces, whereas in chlorine, you have the intermolecular forces, and relative strength, ionic force of attraction is more than the molecular forces. So what you can write is that in KCl, potassium chloride, ions are held, or ions are bounded by ionic bond, and in chlorine Cl2, molecules are, it consists of molecules are, you can write held by the molecular forces, and we know that the ionic force of attraction, is more than the molecular forces. That will be your answer. Now, the first question, the symbol of elements of period 3 of the periodic table are shown. So this is the period 3 of elements. Answer the following questions about these elements. Each element may be used once, more than once, or not at all. Okay. Write the symbol of element which is a malleable. So see, this is elements of periodic 3 and groups is 1. You can write groups as 1, 2, 3, 4, 5, 6, 7, 8. Or what you can write is, this is a group 1, 2, then in between there are transition elements. So this is actually 13 group, 14, 15, 16, 17 and 18 group. Okay. Write the symbol of elements which is malleable. So see, metals are usually malleable. So you can see there are 3 metals over here of group 1, 2, 3, sodium, magnesium and aluminium. So you can write any one of them. Sodium, magnesium, aluminium, any one of them would be correct. Has only 2 electrons in its outermost shell. So if you see, magnesium is of group 2 element. So this will have 2 electrons in the outermost shell. So answer for this is magnesium. Forms an oxide which leads to acid rain. Now acid rain is, see, the non-metal oxides, they are acidic in nature. So it's obvious that that will be a non-metal among phosphorus, sulfur or chlorine. So it's actually the sulfur which forms H2SO4, the sulfuric acid, which contributes to the acid rain. So here we will write sulfur. Forms an ion with a 2- charge. So 2- charge is again will be sulfur. As you can see, it's a group 16 and it has 6 electrons in the outermost shell. So it will accept 2 electrons. So here also sulfur. E part is extracted from an ore called bauxite. We know that bauxite is actually Al2O3. So it's an ore of aluminium. So aluminium. It's saying does not, oh sorry for this. It's saying does not form an oxide. So see, over here is the inert gas of group 18, argon. So because this is inert, so it is not going to form any oxide. This is Ar, argon. Forms an oxide with a macromolecular structure. So see, macromolecular structure, so it's the Si, silicon, which will form the macromolecular structure. The answer is Si. Forms an amphoteric oxide. See, amphoteric metals are those which reacts with acid as well as with the bases. So among these, amphoteric is aluminium, Al. Exists as diatomic molecules. We know that diatomic molecules is this halogen group, chlorine, Cl2. It exists at Cl2. So we write here Cl. Now form the binary compound with hydrogen, that is a strong acid. Form the binary compound with hydrogen. Among this is again Cl, actually which forms HCl. This is the strong acid. So your answer will be Cl only. Now next question. Silver has an atomic number of 47. Okay. Naturally occurring atoms of silver are Ag 107 and Ag 109. So these are the nucleon number, the total number of nucleons, where the atomic number of both of them is 47 only. Okay. State the name given to atoms of same element with different nucleon numbers. We all know that they are isotopes. Isotopes. So isotopes are those which have the same proton number but they differ in the number of neutrons. Means their nucleon number is different. Complete the table to show the number of protons, neutrons and electrons in each atom and ion of silver shown. See, silver they have given Ag 107, 47 and this is Ag plus, so this is an ion, okay, which is 109.47. So number of protons, this will have 47. Neutron, you do 107 minus 47, 107 minus 47, so that will be 60. Electron, now this is an atom, so overall charge is neutral and the number of electron is equal to the number of protons, so this is also 47. Now this is an ion, proton will be 47, neutron will be 109 minus 47, so here number of neutron is 62. And the electrons, see, this is an ion, so that means, see, this is an ion which has positive charge, that means they have lost one electron, so this will be 46. Okay, complete this definition of relative atomic mass. Relative atomic mass is the mass of naturally occurring atoms. So relative atomic mass is write average, or you can write mean. So relative atomic mass is the average mass of naturally occurring atoms of an element on a scale where the dash atom, so here is the carbon 12 atom, this is basically the C12 carbon 12 atom, has a mass of exactly 12 units. A sample of silver has a relative atomic mass of 108. Okay. Deduce the percentage of Ag 107 present in a sample of silver. So see, they have already given you the two isotopes of silver, which is 107 and 109. So 107, 109. Now this 108 lies exactly in between them. So what would be the ratio? Is 50% of each. The average of 107, 109 is 108. So you write, deduce the percentage, so that will be 50%. Silver nitrate is a salt of silver made by reacting silver oxide with acid. Write the formula of the acid which reacts with silver oxide to form silver nitrate. So see, it's a salt of silver by reacting the silver oxide with acid. So the acid, since this is a nitrate, so acid should be nitric acid, HNO3. This will be the acid. Now, C part. Aqueous nitrate is a colorless solution containing Ag plus aqueous ions. Okay, silver nitrate. Describe what is seen when aqueous silver nitrate is added to aqueous sodium iodide. So see, this is basically an anion test. Here, this is an anion test when aqueous silver nitrate is added to aqueous sodium iodide. See, basically this is an anion test. So anion test basically you have for chlorine, bromine and iodine. You should know this. So for chlorine you get white PPT. For bromine is basically like the cream one, and iodine is yellow PPT, yellow precipitate, which is actually sodium iodide, which is yellow in color. So what you see is that is yellow. What you will write is that yellow precipitate, yellow PPT, which stands for the precipitate. Write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium iodide. Include state symbol. So see, the reaction is basically between AgNO3 silver nitrate plus sodium iodide. So only writing the ionic equation. So here this will be Ag plus, which is in the aqueous form, and then plus iodide ion, which is again in the aqueous form, to give, this gives AgI, this is silver iodide, which is a precipitate, which is actually solid, right here solid, precipitate which is yellow in color. So this is yellow color precipitate. Okay. In a positive test of aqueous nitrate ions, so see, this is a positive test. Aqueous nitrate ions aqueous sodium hydroxide and one other substance are warmed with the nitrate ions. Name this other substance and the gas form. Now see, it's simple. When it's nitrate ions, so the gas will be ammonia. Gas will be ammonia. And name the other substance in the gas form. So what happens over here is so nitrate ions, sorry for this, nitrate ions, NO3 minus is changing to actually ammonium ion, and this is actually a cation test, and this is done by the substance aluminium. When silver nitrate is exposed to sunlight, silver is formed. Okay. Name the type of reaction which needs light to make it happen. So basically the type of reaction, which requires light is actually a photochemical reaction. Photochemical reaction. Members of one homologous series only react with chlorine in the presence of sunlight. Okay. Name the member of homologous series. So see, homologous series is basically this is an example of actually substitution reaction. So here is basically you can write alkane. So in alkane you can write anyone. You can write methane, or as well as you can write ethane. So these are a member of homologous series. Any one of them would be correct. Name two products that form when a compound in one reacts with chlorine. So see, if we are taking methane, CH4. Basically this methane, you can write this as C and H like this. So when it reacts with chlorine, which is Cl2, and we write it like this, Cl single bond. Now what happens is that this hydrogen is removed and this chlorine is added to it. And this hydrogen then combines with one of the Cl atoms to form hydrogen chloride. So the reaction will be like this. The products will be, so here you write H, Cl, this is added, plus HCl. So this thing is known as chloromethane, or you can write methyl chloride. So I'm writing methyl chloride, and the other is HCl, hydrogen chloride or hydrochloric acid. You can just write HCl, hydrochloric acid, that will also be correct. Sodium hydrogen carbonate is found in baking powder. Okay, when sodium hydrogen carbonate is heated, it forms three products. Twice of NaHCO3, you can see it forms Na2CO3 plus H2O plus CO2. Okay, name the type of reaction that takes place when sodium hydrogen carbonate reacts in this way. See, basically you are taking a substance, you are heating it, and it is being you see its constituents. So this is what? This is decomposition, but by heat. So what is it? This is thermal decomposition. Thermal decomposition. So this is thermal decomposition. Okay. Now, calculate the volume of carbon dioxide formed at room temperature and pressure when 12.6 gram of NaHCO3 is heated using the following steps. You have to determine the mass of one molecule, 1 mole of NaHCO3. So basically 1 mole is this NaHCO3, writing the molecular, their masses. So you know Na is 23, hydrogen is 1, carbon is 12, and there are 3 oxygen to plus 16 into 3. So substituting this in calculator, you get 84 grams. Okay. So one mass of 1 mole of sodium hydrogen carbonate is 84 grams. Calculate the number of moles of NaHCO3 used. So the number of moles of NaHCO3 used will be, see what is the mass given? 12.6, and what is the molar mass? 84. So to get the number of moles, you do 12.6 divided by 84, which is substituting this in calculator, you get 0.15. So this is 0.15 moles. Okay. Now you have to find the number of moles of carbon dioxide formed. See, for this you have to go to this reaction. As you can see, this is a balanced reaction, so this is 2. So there are 2 moles and you have 1 moles of each. So over here you can see 2 moles of NaHCO3 is producing 1 mole of CO2. So 2 moles of NaHCO3 is CO3. 2 moles of NaHCO3 is producing 1 mole of CO2. Okay, so 1 mole of NaHCO3 will produce half mole of CO2 and 0.15 moles of NaHCO3 will produce over here. So 0.15 moles of NaHCO3 will produce 1 by 2 into 0.15, which is 0.075 moles. So over for the carbon dioxide, you can write 0.075 moles. Okay, calculate the volume of carbon dioxide formed at room temperature and pressure. Now again, going back to this, we see the number of moles of CO2 produced is, the number of moles of CO2 produced is actually 0.075. So we know that 1 mole of any gas occupies 24 dm cube. So this is actually equals to 1 mole. So 0.075 moles will be 0.075, you just multiply times 0.075 times 24, which comes out to be 1.8 dm cube. That's the answer. Lime water is aqueous calcium hydroxide. Carbon dioxide turns lime water milky because a white precipitate forms. Write the formula of calcium hydroxide. Yeah, so calcium hydroxide we know is CaOH whole twice. This is calcium hydroxide. The white precipitate that forms when lime water turns milky is actually calcium carbonate. So this is limestone, the white precipitate because of which this lime water that turns milky, because this is white in color, so it's calcium carbonate. Give the name of the process that is used to produce large molecules from monomers. So as we know, monomers, they combine together to form a large molecule. That process is called polymerization. Polymerization. So that process is polymerization. To separate oxygen from liquid. Now see, it's a liquid air, from liquid air. So it's a liquid air. So we are separating liquid according to their different boiling points. So this answer of this will be fractional distillation. Now, to make ethanol from glucose, this is done by the process called fermentation. D part, to separate water from aqueous sodium chloride. So see, this is an aqueous sodium chloride, means first we have to boil the aqueous sodium chloride so that we get water vapor, and then again we have to condense it back to get water. So this process will be distillation. To produce aluminium from aluminium oxide in molten cryolite. So basically it is the electrolysis process in which we pass electricity in a molten cryolite to get aluminium. So the process will be electrolysis. To separate the products of hydrolysis of long chain carbohydrates. So this is actually chromatography. And to separate aqueous solution from an undissolved solid. Now see, there is an undissolved solid, so you can filter it. So the answer for this will be filtration. Okay, coming on for the next question. Complete the table 2. Deduce the number of protons, electrons and neutrons in the boron atom and chloride ion shown. Identify the atom or ion represented by the final row. Okay, so boron, this is 11,5. As you know, this is the nucleon number, which means the number of protons and neutrons, and this is 5, which means the number of protons. So the number of proton is 5. Since this is an atom only, so number of electrons will also be 5. The total positive charge is equal to the total negative charge. Number of neutron, you do 11 minus 5. For this, you do 11 minus 5, which is 6. So right here 6. Okay. Now chlorine. Now this is an ion. As you can see, Cl minus. It's 1 minus ion. So number of proton is 17. Number of electrons will be 1 more. Minus means it has more, 1 electron more. So you write here over 18. It has 1 electron more. Number of neutrons, that will be 35 minus 17, which is 18 only. So number of neutrons is 18. Now the last row. Number of protons is 24. Number of electrons is 21. Number of neutrons is 30. As you can see, there are less number of electrons. So this will be positively charged. See, the proton number is 24. That means the atomic number is 24. So from the periodic table, you can see the element whose atomic number is 24. Because I know it's chromium, so I am writing here chromium, and this will be 3 electron less, means this will be 3 plus, and here it will be 24 since the atomic number remains same. And for the number of nucleons, what do? You do 30 plus 24, which is 54. So over here this will be 54. Coming on to the next question. Now, sodium reacts with fluorine to form sodium fluoride, NaF. Now, you all know NaF is an ionic compound. Write the chemical equation for this reaction. So, for this you write sodium, fluorine is F2. So, that gives NaF, which is sodium fluoride. Now, you have to balance it. So, see, there are 2 fluorine atoms. So, you write here 2. To balance sodium, write here 2. This will be our answer. Or this you can say the complete chemical equation. Sodium fluoride is an ionic compound. Complete a diagram to show the electron arrangement in the outer shell of the ions present in sodium fluoride. Give charges on both the ions. See, as we know, sodium will donate 1 electron to fluorine. So sodium has 2, 8, 1. So it will donate this electron to fluorine, which has 2, 7. So this will be 2, 8, and again with the positive charge, since the sodium is giving out the electron to fluorine, and this will accept that electron to get 2, 8, which will have 1 negative charge. So first we write here plus 1, because sodium will be plus 1 and fluorine will be minus 1. So now 8 electrons of sodium, 1, 2, 3, 4, 5, 6, 7, 8 electrons of sodium, and fluorine will have 7, 1, 2, 3, 4, 5, 6, 7, and 1 electron which is donated by sodium or given by sodium is accepted by the fluorine. So here is the electron for the fluorine, which is given actually by the sodium. Now, aqueous sodium fluoride undergoes electrolysis. Now state what is meant by the term electrolysis. So we know electrolysis is the breaking down of an ionic compound in its molten or aqueous state by the passage of electricity. So let's write it down. It's breakdown of ionic compound, in its molten or aqueous state by the passage of electricity. This is called electrolysis. That's how you define electrolysis. Okay, name the products formed at the positive electrode anode and the negative electrode cathode when dilute aqueous sodium fluoride undergoes electrolysis. So first of all, we have to understand that it is dilute, means it contains water. So what are the ions present? Ions present are Na plus, F minus, and H plus, OH minus. So anode. So see, at anode, since it is aqueous, means the H plus and OH minus ions are more. So OH minus ions actually oxidize to form oxygen. So at anode, so it's a OH minus ions which actually goes to the anode. So here it forms oxygen. Oxygen. Cathode. Now see, at cathode there are two Na plus and H plus ions. Now Na is highly reactive, so it will remain its state. It will maintain the state of ion, and the H plus ion will undergo the reduction. Because it's H plus ion, it will take one electron to form hydrogen. Yeah. Go to the next question. Now molten sodium fluoride undergoes electrolysis. Name the product formed at the positive electrode anode and the negative electrode cathode when molten sodium fluoride undergoes electrolysis. See, now it is just molten sodium fluoride. So first of all, we should know what are the ions present. Is Na plus and F minus ions are the only ions which is present. So anode is a positive one. So anode F minus will go towards the positive one. So over here this will be fluorine, and at cathode that will be sodium. Now next question, next part, sorry. Write the ionic half equation of the reaction at the negative electrode. So negative electrode is basically where the sodium is being reduced, sodium ion is being reduced. So you write Na plus 1 electron, that gives sodium atom. So this will be the reaction. Now complete the dot and cross diagram to show the electron arrangement in a molecule of fluorine F2. Show the outer electrons only. So we know that fluorine has atomic number 9. So the electronic configuration is 2, 7. And the fluorine, this F2 molecule, it's a covalent bond, so it's a sharing. There will be one pair of electron which is being shared. So writing for this 1, 2, 3, 4, 5, 6, 7. And for this fluorine, 1, 2 representing it by cross, 3, 4, 5, 6, 7. As you can see, now this pair is being shared. So now they both have 8 electrons and they are being shared. This is also called covalent bonding. Okay, up to next. The melting and boiling points of fluorine and sodium fluoride are shown. Okay, fluorine, so you can see the melting point minus 220, boiling point minus 188. Sodium fluoride, which is quite high, 993 and 1695. Now deduce the physical state of fluorine at minus 195 degrees Celsius. Use the data in the table to explain your answer, the physical state. Now see, again I am making this number line. See, this is minus 220 and this will be minus 188. Now the temperature what they have given is minus 195, which is in between minus 195 in between these two. So over here it exists in the form of gas, this is in the form of solid, and between these two it will be in the form of liquid. So physical state is liquid. Okay, now explanation. Now explanation is basically the temperature which is 195, the given temperature is less than the boiling point, which is minus 188 degrees Celsius, and greater than the melting point, which is minus 220 degrees Celsius. Yeah, that's our answer. Next. Explain in terms of structure and bonding why sodium fluoride has a much higher melting point than fluorine. Okay, your answer should refer to the types of particles held together by the forces of attraction, types of forces of attraction between the particles and the relative strength of the forces of attraction. So we all know that sodium fluoride NaF is made up of ions, so it has ionic bonding which is quite high as compared to the fluorine, which has covalent bond between its molecule, which is also a weaker bond. So that's why it has a very high melting and boiling point, as you can see, as compared to fluorine. It has a very high melting and boiling point. It's because of the very strong force of attraction between its ions, or you can say it has very strong ionic bond. So what your answer will be? Sodium fluoride NaF has a strong ionic bonding between its ions. Ionic bonding between its ions. Fluorine has a weak covalent bonding, comparatively weaker, like weak covalent bonding between its molecules, and so because of which sodium fluoride needs more energy than fluorine to break its bond, Yeah, that's it, the answer. As you can see the answer, I have written